We are now going to tackle the Noether isomorphism theorem. In many ways, this is the culmination of the course. We have, one more section after this, but the Noether isomorphism theorem is the fundamental theorem that you learn in a course like this. And we are going to need some setup first. So suppose that we have a homomorphism. So phi from R to S is a ring homomorphism. All right, so we showed a couple of things in the past. Namely, we showed the image of phi, which is the range, is a subring of S. And in fact, phi naturally lands in the image. So we can think about phi instead as a function from R to the image. So we sort of alter phi by altering the codomain to be the subring image of phi. And so we're going to view phi as a homomorphism from R to just its range. Again, image is just range. That's all that is. Okay, great. Now, by what we've done with kernels, we know that the kernel is an ideal, and we know how to mod out by ideals. So what we're going to do is we're going to do exactly that. So phi, sometimes this is represented as like a diagram. So phi is going to go to the image, and we're first going to look at sort of this quotient map, where we look at all of the things that phi sends to 0. Again, the kernel is the things that phi annihilates. And we're going to declare that everything that phi annihilates becomes 0. And that's what this vertical guy is doing. It's saying, hey, declare the kernel elements to be 0. And there's a natural function, a natural homomorphism that we saw earlier that does this map. Sometimes it's denoted with a pi because it's kind of like a projection. We're going to define a map f from the kernel, from R mod the kernel to the image. And so f is going to be a map that takes us from R mod the kernel to the image. And f is going to send R plus kernel phi to phi of R. So it's really just do phi after declaring the things that phi sends to 0 to be 0. And the content of the Noether isomorphism theorem, so Noether isomorphism theorem, which is going to take up the next couple of videos, says that f is an isomorphism. And this is the fundamental result in this class. This is, something very, very important to understand the proof of, and very, very important to remember. All right, so this is our function. In the next couple of videos, we are going to show that this function is well defined. We're going to show this function is a homomorphism, it's a monomorphism, it's an epimorphism, and therefore it is a isomorphism.